The United States and the Soviet Union began the space race as early as the launching of Sputnik in 1957. The Soviets chalked up an impressive list of firsts until American astronauts landed on the moon in 1969. In planetary exploration, a Soviet robot made the first soft landing on Mars in 1971. 5 years passed before 2 Viking craft from the U.S. touched down on the Red Planet. But these unmanned ships were much more sophisticated than the Russian probe. In 1975, the racers took a breather as astronauts and cosmonauts met in space and shook hands. Hello, I'm Jim Lovell, your host for another adventure in space brought to you by the Eastern Press and NASA. The first film you will see details the adventures of John Young and Charles Duke on the moon in April 1972. While cosmonauts remained bound to Earth's gravity, John and Charlie bounced and skidded across the moon's surface in a lunar rover, with tails of dust shooting out from under their wheels. When they drove up the side of a mountain and looked into the edge of the crater so deep they could not see its bottom. Young made good his boast that the Apollo-16 mission would change the mysterious and unknown image of this part of the moon. 2 U.S. robots did the same for a couple locations on Mars. Vikings 1 and 2 landed there in 1976 after journeys of 1 year and 4 million miles. Both robots scooped up samples of soil and analyzed them for signs of life. No signs were found. However, biologists have not ruled out the possibility that primitive life once inhabited Mars. 1 month before the first Viking left Earth, cosmonauts blasted off from Central Asia and astronauts from Florida. You will witness the historic moment in 1975 when these 2 ships docked. A hatch between the 2 spacecraft was opened, and the crew shook hands and exchanged presents. Many people hoped this would mark the beginning of cooperation between the 2 nations. Perhaps history will repeat itself, and citizens of the United States and the Soviet Union will someday shake hands in space again.
April 16, 1972. Apollo-16, man's 5th lunar landing, sat silently on the pad awaiting its mission. Inside the astronaut quarters, its relaxed crew ate Sunday breakfast. John Young, a veteran of 3 previous space flights, was commander. Ken Mattingly, command module pilot, would conduct orbital experiments around the moon, while Charles Duke explored the lunar surface with Young. April 22nd. Young and Duke would find themselves strapped into a small electric car called the Rover, bouncing across the lunar plateau known as Descartes.
The old water bag is working super. This is going to be a good day, Charlie. Yow! Woo! Man, that's a great big skid. We're doing 10 clicks, Tony. Covered me with dust on that one.
As Young and Duke rode the bucking rover to the lunar formation called Stone Mountain, NASA geologist Farouk El-Baz wrote on a blackboard on Earth, "There is nothing so far removed from us to be beyond our reach, or so hidden that we cannot discover it." René Descartes. As John Young would later remark, Apollo-16 would certainly help prove that René Descartes was right.
Compacted. Almost like a freshly plowed field that's been rained on.
Yet less than 2 days before, it looked as though this would never happen. It was, in Young's words, a real cliffhanger. The Marshall Space Flight Center team was working on a launch vehicle gyroscope problem that threatened to scrub the mission. Less than an hour before liftoff, their advisory to the Kennedy Space Center launch team was go. The liftoff had been perfect.
Propellant tank.
During the 3-day flight to lunar orbit, the problems encountered had been more annoyances than critical, such as paint flaking off the lunar module, and later a jammed antenna in one of the lunar module's several communication systems. All in all, it had been a quiet flight. April 19th, the burn into lunar orbit was right on.
Oh, Houston, Sweet 16 has arrived.
The subsequent maneuvers all went without a hitch. Then the next day, April 20th, Young and Duke undocked the lunar module preparatory to landing, leaving Mattingly in the command module.
Okay, Jim, it was a little rush, but we got it done. Right here, 5-5, Jim, and we're sailing free.
The next maneuver was for Mattingly to burn the main engine of his spacecraft to put it into a circular orbit. But as the lunar module emerged from behind the moon...
No, sir. Copy, no, sir.
No, sir. No, sir.
No circ. In preparing for the circularization burn, Mattingly had found apparent uncontrolled oscillations in the main engine's backup control system. Following mission rules, he did not make the burn.
How long do you think it's going to take them to get rendezvous, Jerry? I think your estimate of a couple of 3 revs.
With the backup system having trouble, only the primary system was known to be usable on the engine needed to get the astronauts out of lunar orbit and back to Earth. However, the lunar module engines could be used if the 2 spacecraft were docked. The first step in the problem-solving technique: stabilize the situation in the safest manner. Get the 2 spacecraft, which had separated, close enough together to dock if necessary.
As they get them back together, get the things back that they want them, get them mentally prepared to do what they're going to do.
But now, don't take that as input. I'm talking out loud. I want to say something else I'm sure of.
I don't see any way we can continue on.
At that moment, the chances for a landing looked pretty slim. But you look at a problem step by step. Step 1 underway, you look at step 2. Analyze the problem as completely as possible within the time frame.
We should make sure that that's gone, but there's no way, you don't have any other redundancy or other routes?
And in lunar orbit, Mattingly flew the command module to a rendezvous as Young talked him in.
Okay, fine. Why don't you tell me what to do there, John? Okay.
Word's coming back kind of initially from North American that they're suspecting a rate feedback.
Building 45 is Jimmy to it.
The team was coming up to speed, not only at the Manned Spacecraft Center, but from MIT in Massachusetts to North American in Southern California. Isolate the trouble, simulate it, evaluate it.
You can't use it. If you get a broken wire, you don't know it's going to come back again.
You know, like I'm drifting the other way. Not according to my needles. Okay, I'll believe your needles.
Of course, then you would have had no options. Okay.
Go ahead.
I mean, then it's full speed ahead.
I just don't much see how we can make it on this next rev. I think you guys ought to continue to work.
So you'd only do it if you had a failure on the primary. Well, how would you ever get the damn thing trimmed then?
Well, I would. If I had a failure in a primary, I'd shut it down.
Well, we must be going in the right direction then. Well, yeah, you're going to get there.
Yeah, but I want you guys to go simulate it.
Isolate, simulate, evaluate. The results were coming in. It was beginning to pay off. The simulator tests and other data were showing that with the engine on, the oscillations would do no harm. Despite the earlier pessimism, it was beginning to look pretty good.
Okay, when you come up on AOS, on the next rev 15, we'll give you a go or no-go for another try.
Manned Spacecraft Center Director, Dr. Christopher C. Kraft, Jr. just came back into the control center after having attended a meeting by management people in one of the back rooms, and the situation is go for landing.
Well, have at it, babe. So we're going to try it. And,
You do have a go for another try here at PDI on Rev 16.
Once more, they would pass behind the moon. And on the next revolution, John Young and Charlie Duke would start their swift descent to the Descartes Plateau.
Okay, filter initialization looks good.
Right on. Feel that beauty? Come on. 200. Pro. Pitch over. Pitch over. And here it is. Gator, Lone Star. Call me the thing, Charlie. Okay, 40 degrees, 38 degrees. Right Helmet on dot, north ray. Okay. Looks like we're going to be able to make it, John. There's not too many blocks up there.
Ryan, you go for landing.
Right now looks pretty good.
Go, Hunter. Okay, any words in this?
Go, flat. Looking good. It looks good. Transport rate's going down.
Look at the ag.
That comes the shadow. Okay, down at 3, 50 feet. Down at 4. Give me one click up. You're backing up slightly. Okay, 2 down. Stand by for contact. I'm going to let her down. You level off. Let her on down. Okay, 6%. Plenty fat. Contact. Stop. Boom. Wow! Come on, man. Oh, the run is finally here, Houston. Fantastic.
The original plan had called for Young and Duke to get out and explore shortly after landing. However, the near abort had lasted 6 hours. The tired astronauts would sleep.
Okay.
April 21. Mission Commander John Young stepped onto the Descartes formation, 11:58 a.m. Eastern Standard Time.
They are mysterious and unknown Descartes. Island planes. Apollo 16 is going to change your image.
While their activities were monitored by Mission Control, Young and Duke were also observed by scientists, located across the hall in the Science Support Room. After unloading the rover from its storage bay in the lunar module, they planted the flag.
Hey, John, this is perfect with the limb and the rover and you and Stone Mountain and the old flag. Come on out here and give me a salute. Big Navy salute. Off the ground, before. There we go. Good.
Young set up an ultraviolet camera to provide the first astronomical observations from the moon. He took pictures of the Earth's upper atmosphere and magnetosphere and their interaction with the solar wind. He also photographed the interstellar gas present throughout space and the ultraviolet halos that appear around galaxies. Astronomers have long wanted a telescope on the moon. Perhaps this experiment would show the moon an ideal base for future astronomical observations.
you want 2 pans.
Yeah, we would like to. John said.
I'm not leaning on
Duke
it.
drilled a hole into which a heat flow probe was to be placed, part of one of the experiments attached to the station. As Duke drilled, Young set up the central station and the remainder of the experiments. Then, what many considered the biggest disappointment of the mission.
Probably just some rocks down there in the regolith, Tony. You know, it looks, I bet it's just like the side of that fresh crater we saw back near the limb. Charlie, what? Something happened here. What happened? I don't know. Here's a line that pulled loose. Uh-oh. What line is it? That's the heat flow. You pulled it off. God, I'm sorry. I didn't even know it.
But that means you've got to mate all those wires, separate wires in there, and have them insulated from one another.
That's right.
And if that doesn't occur, what are the chances of shorting out the central station?
Well, that's another one that they're working.
On Earth, they tried to figure a way to fix the heat flow.
Sound doesn't travel too good in the back.
On the moon, the astronauts continued with the other experiments. Young placed a series of sensors in the soil, then fired explosive charges, mapping the lunar subsurface much as geologists on Earth use explosives to search for oil.
4, 3, 2, 1, fire. Stuck in the ground and I try to get this
three over there now.
They continued to sample the area and activate the experiments. Then they returned to the rover and prepared for their first trip away from the landing site in search for geological samples.
And here we go.
Their first traverse would take them about 1 kilometer west of the landing site. They would make 2 stops to collect samples and conduct experiments.
You have 10529 in your flight plan.
But it couldn't pick a better spot. John, you're just beautiful. That is the most beautiful sight. What's that? You're standing there on the rim of that crater.
This guy, I don't really know. We're going to have to use a hand.
Young used a portable instrument to measure the local magnetic field. He would later record the most intense magnetic field ever found on the moon, far higher than scientists ever suspected.
What's that, Charlie? It's really some crater. As you come around there, there's a rock in the near field on this rim that has some white on the top of it. We'd like you to pick it up as a grab sample. This one right here? That's it. This one right here? That's it. You got it right there.
Okay, we copy that.
There would be one more stop before they got back to the lunar module to close out this EVA. With Duke acting as photographer and Young as driver, they put the rover through a full test.
Man, you are really bouncing. Is he on the ground at all? That's 10 kilometers. Huh? He's got about 2 wheels on the ground. Okay, turn sharp. I have no desire to turn sharp. Okay, here's his Sharpie. Hey, that's great. He's a big rooster tail out of all 4 wheels. And as he turns, he skids, the back end breaks loose just like on snow. Come on back, John. Hey, the DAC is running. Man, I'll tell you, Indy's never seen a driver like this. Okay, when he hits the craters and starts bouncing, it's when he gets his rooster tail. He makes sharp turns.
Then it was back to their lunar base, activate experiments, and close out EVA-1.
Be wise exercise, is that right? Physical fitness, gym level?
Hey, that's right. Please don't take pictures of the hot dogs. Showing the low residue, high protein diet.
On Earth, the scientists took a break. Tomorrow would be another busy day. April 22nd.
The lunar surface temperature in the sun should be around 135 degrees today.
Today they were headed a little over 4 kilometers south to climb their rover up the side of Stone Mountain.
Man, we are really going up a hill, I'll tell you.
Their first station, a crater 700 feet above their lunar module.
Wow, what a place. What a view, isn't it, John? It's absolutely unreal. We really come up here, Tony. It's just spectacular. I have never seen it. All I can say is spectacular, and I know y'all are sick of that word, but my vocabulary is so limited.
Let's see what we can do. If we got the break soil, we got certainly something. We could go to one-man sampling and maybe do it.
They would make a total of 6 stops on this traverse, collecting samples from large rocks down through the intermediates to the smallest soil particles. They would operate experiments measuring the strength of local magnetic fields to measuring the resistance of the soil to compaction.
'How far away is that crater?
Man, we come a long way. Hey, John, it's easier to go straight across. That was fun. Well, I haven't had any trouble. Okay. I have a tough time walking up there.
The sampling time used up, it was time to return to the rover and head back to the lunar module.
And they did it in 2 minutes less travel time than ever
10 minutes
pre-planned. Fantastic.
Tony, how about an extension, you guys? We feeling good. If Dad all we're going to do tonight was sit around and talk.
But with the limited oxygen and water in the backpacks, it was finally time to close out EVA-2.
Okay.
Now I think they realize that it's not more, well, a gee whiz, like my friends say, thrill, but it's real exploration, and this is much more serious and much more important for the future of mankind than just a plain exploit, a technical or technological exploit. This is exploration.
Ray Bradbury claims that what mankind sees in the exploration of space is his first chance at immortality since he invented religion.
That about gets it.
April 23rd. The decision had been made not to try and fix the broken heat flow experiment because of the time and complexities involved. Traverse number 3. Today, Young and Duke would head north about 5 kilometers to North Ray Crater, the largest lunar crater to be sampled by men.
Outstanding.
Hey, Tony, it seems to me this is a more subdued surface over here than going towards South Ray. Oh, spectacular. Just spectacular. Wow. Sorry, Charlie. Beautiful. I gotta keep my eye on the driving. That's great.
Jack, that's a good point to remember. All 3 crews now tend to think they're there before they get there.
I remember.
Man, does this thing have steep walls. They said 60 degrees. Now, I tell you, I can't see to the bottom of it, and I'm as close to the edge as I'm going to get. That's the truth.
Now the routine, if anything on the moon can be called that. Test, collect, photograph. Keep moving. Time is precious on the moon.
The crater, they look like drill holes is what they look like. You do that in West Texas and you get a rattlesnake. Here you get permanently shattered soil.
How about rolling that one over?
No way.
Then, one of the most spectacular discoveries of the mission.
Look at the size of that biggie. It is a biggie, isn't it? It may be further away than we think. No, it's not very far. It was just right beyond you.
And we better press on for the big boulder?
Okay, we're headed that way. You get the tongs, John? Yep. I'll carry the rake.
That big black dot.
Fantastic. Like right here.
If we could see to the bottom, we could say for sure if this big black rock is right out of the bottom. But my guess from the old photographs is it probably is.
Okay, that sounds like a good guess.
God, you mean they weren't at it? No. It looked like they were standing right there.
Look at the size of that rock.
I'm curious what they're going to look like when they stand next to it.
We can see. The closer I get to it, the bigger it is. Yeah, but look at the permanent shattered part, Charlie. On this side over here? Yeah.
And as our crew slowly sinks, we bet upon disappeared into the sunset.
Well, Well, Tony, that's your house rock right there. Very good. Don't get too near the edge of that thing. It falls off. Look over at your right. It falls off pretty good. Yeah, I know.
Yeah,
keep going. Can't believe got it. I can't either. Okay, let's go on back. I am. Be right with you.
And we'd encourage you just to look for some variety.
But now it was time to head back to their base and close out the EVA.
All right, we think you could just about head south now.
Yeah, the only reason.
That's it. We're going home again, jiggity jig.
During the previous EVA, a section of a rear fender had come off the rover, causing the astronauts to receive occasional showers of lunar dirt.
And that's a beautiful sight.
Young parked the rover, then moved out to join Duke, enter the lunar module, and prepare for liftoff.
Boy, Houston, the beauty of this place is absolutely incredible.
Smile, FAO. Don't be mad. We'll get it up there. See how nice and leisurely it's been? That's the way it should be, getting ready for ascent. 10 seconds.
What a ride, what a ride. Midcover's on time.
Together in orbit, the two spacecraft pirouetted, each inspecting the other.
This is one of the fastest maneuvers I've made in a long time.
The inspections complete, the command module and lunar module maneuvered to docking. John Young, Ken Mattingly, and Charlie Duke, reunited aboard the command module, settled down for tomorrow's tasks. Jettison the lunar module and burn out of orbit to come home. April 25. Ken Mattingly left the confines of the command module cabin, 173,000 miles from Earth. As he orbited the moon, he had not only made visual observations, he had been operating a complex series of experiments. Many of these had returned instant data to Houston. Two had taken thousands of high-resolution pictures of the lunar terrain. Now, Mattingly retrieved the film canisters and made his way back to the cabin with them, as Charlie Duke stood in the hatch to help him. It had been quite a mission. In John Young's words,
I think we've seen as much in 10 days as most people see in 10 lifetimes.
April 27, the last day. The crew looked out their windows through the 5,000-degree fireball of re-entry at their native planet.
Apollo-16, this is recovery. Welcome back. Go ahead.
That is beautiful, isn't it?
Now they're blooming. Beautiful. Beautiful. There they are. Beautiful. Beautiful.
Apollo Control Houston, an observer on the Ticonderoga estimates a distance from the ship about 1 mile.
Just got it on in time.
There you go, Joe.
You saw an example of goal-oriented teamwork in action. The kind of thing that made this country great and the kind of thing that's going to keep it that way.
A real smooth shot. Every bit of it, Jerry. You brought him in beautifully.
Well done, young man. Outstanding.
I cannot touch that cigar anymore. I cannot.
I told them they're going to improve the skyline. We're in trouble.
Mike, congratulations. Well done.
Yeah, you get one more.
Well done.
One more to go.
I just hope.
Of all the planets in the solar system, Earth and Mars, the third and fourth planets from the Sun, are the most similar. But despite the similarities, Mars is essentially like no other planet. It is a unique world. It was an elusive and baffling planet to astronomers for hundreds of years. Through early telescopes, it appeared to be a small red sphere, later estimated to be about half the size of Earth. One of the earliest known representations of the planet, drawn in 1659, indicated markings on the surface, and by the movement of these dark patches across the disk, it was shown that Mars rotated on its axis in a period only a little longer than Earth's, about 24½ hours. It was observed, too, that the tilt of its axis, like the Earth's, exposes its polar regions alternately to the sunlight. Thus, each hemisphere has a summer and winter period. And since Mars orbits the Sun in 687 Earth days, one Martian year and each of its seasons is almost twice as long as Earth's. Later mappings of the planet displayed light and dark regions identified erroneously as continents and oceans. The land masses red as the sandstone districts on Earth, the water a greenish blue. In 1877, an Italian astronomer, Giovanni Schiaparelli, discovered what he called canali, or channels, resembling, he said, the finest threads of a spider's web drawn across the disk. In America, Percival Lowell founded an observatory to study these Martian features. Massive irrigation systems, he called them, designed to carry water from the melting ice caps to the major centers of a dying civilization. Science fiction writers populated the cities with terrible creatures of heroic size, with skills beyond Earthman's dreams. In the 1960s, 3 Mariner spacecraft flew by Mars and photographed about 10% of the surface. Gone were the canals, gone were the cities, gone the brilliant and sinister Martians. The photographs revealed a cratered landscape much like the moon, waterless and apparently hostile to life. But in 1971, the Mariner 9 spacecraft orbited Mars and transmitted more than 7,000 photographs of the planet to Earth. The extensive mapping revealed a new and unexpected world. The southern hemisphere, seen by earlier spacecraft, flattened and gouged by the impact of meteorites. The northern hemisphere, a vast plain with few craters, and rising from the plain, a great dome called Tharsis, topped by giant volcanoes. The plateau that joins the two hemispheres is cut by a vast and deep canyon.
and by channels with the characteristic patterns of stream beds on Earth. Some of the channels suggested that water may once have flowed on Mars, and thus life might have evolved and possibly adapted to Mars' changing conditions. And then in 1975, 2 Viking spacecraft were launched, each of which was programmed to land a robot on the Martian surface. One of its principal objectives was to test for the presence or absence of living organisms. A communication system linked the spacecraft to the Mission Control and Computing Center in Pasadena, California. On June 19, 1976, the first Viking arrived in the vicinity of Mars after a year-long journey of more than 400 million miles. Once in orbit, its cameras were turned to a detailed examination of the landing area. Imaging teams on Earth scanned some 800 photographs covering a territory about the size of Texas. The chosen landing site was a flat expanse with a few impact craters, one of the lowest regions on the surface. On July 20th, 1976, flight controllers ordered the lander to separate from the orbiter.
5, 4, 3, 2, 1, separation. Descent sequencing, we're at mission event word 0, we have VL separation.
Because of Mars' great distance from Earth, the signal traveling at the speed of light, 186,000 miles per second, took 19 minutes to reach the spacecraft. This necessitated a completely automated system on board for carrying out the landing maneuver. During the lander's descent, its instruments analyzed the properties of the thin Martian atmosphere.
9,000 feet coming up on quarter bar pretty soon.
Good roll attitude hold.
Pretty close to quarter bar. Firm quarter bar. 2 loops in the high. Got it. We have quarter bar. Lander confirmed parachute deployed. Recon 1, TM2. Drive sync. UHF minus 105. Format 3 is in sync. Alright. Format 3 in sync. Leg deployed. 4,800 feet, 177 feet per second.
Confirm roll maneuver.
Parachute separation. Roger. Minus 105. 0.3 gauge. 2,600 feet, 188 feet per second.
2,600 feet! 2,600 feet!
366 feet.
73 feet per second.
Come on.
ACS is close to vertical.
Nav is green for touchdown.
ACS is green, 1.5 degrees per second max, 0.2 Gs.
Touchdown, Win. Fantastic. 16 kilobits confirmed. Yes, we have a touchdown time of 12 hours, 12 minutes, 07.1 seconds.
A job very well done. Outstanding, great, navigation, perfect. I'm assuming that we must be sitting right on the X. So that's the smooth area. So everybody just did fabulous and couldn't be more pleased. Thank you.
25 seconds after landing, one of the 2 cameras was initiated and scanned the first picture of the Martian surface.
About a half an hour later, when it started to come back from the orbiter, and we got the first 7 lines on the TV monitors, you could see gray and white light levels, and we knew there was something there. Look at the beautiful rocks. Fantastic. And all of a sudden, we were looking at the surface of Mars, and it was clear, it wasn't dusty, it was sharp. And when we got to the end of that first picture, with the dust and small pebbles in the footpad, it was just, it was really a miracle.
In an instant, the picture was wiped off the TV monitors, and behind it came the filling in of the second picture, a long panoramic view that covers 300 degrees and extends from the lander to the horizon. It disclosed a sector of the basin called Chrysoplanitia, covered with sand or dust and littered with rocks. The following day, Viking sent back the first color picture. A fine dust, red or yellow-brown, covers the ground. The sky is a light tint of the same color due to the particles of dust suspended in the air. 45 days after these historic events, Viking 2 landed at an area 4,600 miles northwest of Viking 1's landing site. A vast plain, littered too with rocks resembling those on Earth, produced by volcanic processes or by meteorite impact. While the landers conducted experiments on the surface, the orbiters swinging around the planet measured variations in moisture and temperature and took high-resolution photographs of the Martian terrain. Four and a half billion years ago, the planets were formed from the gas and dust of the solar nebula. In the formation of a planet, heat is released and remains embedded in the growing mass. Because the heat can't escape as rapidly as the mass is growing, a point is reached eventually where the interior melts. On Mars, the heavier material sank toward the center, and the lighter material rose to form a crust at the surface. And this crust contained ice and other condensates. A later stage may have occurred where molten rock intruded into the crust and melted the ice, causing a slurry of water and rock and dust to flow across the surface. Some observers believe that such a process may have been the cause of the major channels which we see on the surface of Mars today. But others believe that in Mars' first billion years, the atmosphere may have been warm and dense enough for rain to fall and for rivers to flow. Gradually, the original thick, wet, and warm blanket of the atmosphere evolved into the thin, dry carbon dioxide atmosphere we find there today. Because of Mars' low atmospheric pressure and low temperatures, water can't exist in liquid form. It must either freeze or evaporate. But while there are no oceans or rivers on Mars, there is more water in total than anyone had expected. The residual polar cap in the north, which remains after the hottest part of the northern summer, is water ice mixed with dust. And the measurements of the seasonal behavior of water vapor over the planet suggest that there is a vast reservoir of ice beneath the surface, so that one can think of the residual polar cap as the tip of an iceberg protruding from a sea of rock. At lower latitudes, the water vapor condenses to form clouds that ride high in the atmosphere or swirl around the slopes of Martian volcanoes. And further south, in the canyons and valleys, there is frequently an ice haze seen to form and evaporate in the early hours of the morning as the sun warms the atmosphere. On Earth, the ocean's heat and moisture and the heat and air currents over land masses interact to produce complex weather patterns. On Mars, because of the absence of large bodies of water and of massive cloud covers, the weather doesn't vary much from day to day. Like a remote weather station on Earth, Viking's meteorology instrument measures Mars' atmospheric pressure, temperature, wind speed, and wind direction. Temperatures range from minus 122 degrees Fahrenheit just after dawn to minus 22 degrees in the mid-afternoon. Light winds from the east in the late afternoon change to light winds from the southwest after midnight. Maximum wind speed is 15 miles per hour. But in the early summer, the heating of dust particles in the air generates violent dust storms in the low regions of the planet. Driven by winds that reach 150 miles an hour, they may blanket the entire planet in a few days.
In order to understand the geology and physics of wind-blown particles on Mars, we're conducting a series of experiments using this enormous space environment chamber here at NASA's Ames Research Center. We've placed an open circuit wind tunnel in this chamber, and we're able to operate at atmospheric surface pressures comparable to those on Mars. In this particular series of experiments, we have placed a crater model in the tunnel floor, and we want to determine the zones of erosion and deposition around the crater. In this particular case, we're going to let the wind blow across the crater and see what those zones of erosion and deposition are like.
The light and dark streaks associated with craters are the most common features on the surface of Mars related to wind. The light streaks are deposits of fallout from the global dust storms. The dark streaks are regions from which a thin layer of light material has been removed, revealing a darker underlying surface. These streaks serve as wind markers. Their patterns define the wind flow. To the geologist, the features seen in the tens of thousands of photographs transmitted by Viking are the visible signs of the enormous forces and processes that have shaped the surface of Mars. The excavation of large basins and craters by the impact of meteorites and asteroids. The raising of mountains by the action of volcanoes. The faulting and subsidence of the crust as the planet expanded. And the cutting of channels by water, or abrasive particles driven by winds over a period of tens of millions of years. The key to the age and sequence of these features is found in the number and condition of craters. Those areas with fewest craters are assumed to be the youngest. Here, a fresh crater overlies an ancient eroded one. Here, the rim of a crater is eroded by water or wind. And here, adjacent to a fresh crater, is one of a cluster of crater rings, craters that have been buried to varying depths. Over millions of years, the repeated flows of lava built the volcanic mountains of Mars. 12 are larger than any on Earth. The largest, Olympus Mons, rises 3 times higher than Mount Everest and is broad enough to cover the whole chain of volcanoes that form the Hawaiian Islands. The great gash that cuts through Mars' equatorial zone is Valles Marineris, a mighty canyon system that extends over an area more than 3,000 miles long and up to 400 miles wide, and drops 4 miles below the flat cratered surface of the plateau. Canyon walls are gullied, dissected by tributary canyons, or scarred by catastrophic landslides, leaving steep cliffs and great fractured surfaces. Extending for 30 miles on the canyon floor is a field of sand dunes, suggesting that some of the debris produced by the collapse of the canyon walls was removed by wind. These ancient channels that resemble dry riverbeds on Earth could have been formed by primeval rainstorms. But the vast channel systems that start in areas of collapsed terrain, with broad streamlines extending hundreds of miles across the lowlands, and teardrop-shaped islands soaring to thousands of feet above the channel bed, testify to a process without any parallel on Earth. Viking also photographed the 2 cratered moons of Mars, Phobos, the inner moon, marked by striations which, on closer view, resolve into grooves several miles long. And Deimos, the smaller outer moon. Viking, traveling at 3,800 miles an hour and passing only 30 miles away, could observe boulders on the moon's surface, some as large as 100 feet across. The geologic record of the planet suggests that Mars, like the Earth, has experienced periodic changes of climate. The best evidence of this is seen in the strange spiral patterns of Mars' polar regions. The dark bands are scarps or cliffs of bare ground within the North Polar ice cap. On each scarp are numerous small terraces eroded from layered rocks. This is a model of layered terrain, an area about 40 miles across. It is believed that the large scarps and the small terraces represent two different cycles of climatic change which occur simultaneously. Because of Mars' oscillation in its orbit about the Sun, the polar regions are alternately warm and cold for periods of tens of thousands to millions of years. During the cold period, mixtures of dust and ice were deposited in a series of near horizontal layers, obscuring the underlying topography. Then a period of warmer climate followed, and erosion set in, cutting deep valleys into the icy mass of the polar caps. After the erosion cycle, new layers were laid down, and another episode of erosion followed. This oblique truncating of one set of terraces by another indicates that the climate turns on and off, the first geological evidence for cyclical climatic change on a planet other than the Earth. The speculations about changes in the atmosphere and climate were closely related to the notion that life in some form might exist on Mars. On Earth, life developed several billion years ago, at a time when the overall properties of Mars and the Earth were very similar.
Now, over the ensuing billions of years, Mars and the Earth evolved separately. However, Mars today still has chemicals on its surface, an atmosphere, temperatures and pressures within which we believe life can exist. The Viking lander was equipped with 3 life detection experiments designed to test for chemical changes caused by life processes that are familiar to us on Earth. On Earth, all living organisms interact with the environment through a process called metabolism.
Animals, for example, take oxygen from the environment and use it to combust food, thereby obtaining energy. At the same time, they release carbon dioxide and other waste products into the environment. Green plants and some microorganisms do the reverse in the process of photosynthesis. They remove carbon dioxide from the environment, and using sunlight as the energy source, they convert the carbon dioxide into organic matter and release oxygen into the environment.
If the experiments on Mars indicated that similar processes were occurring, then we would presume the possible existence of organisms on that planet. Well, our results on Mars in certain experiments gave us data that seemed to mimic the metabolism of living organisms. However, careful analysis of that data indicates that it is probably the result of chemical rather than biological processes.
On Earth, all biological systems are based on organic chemistry, and it was believed that life on Mars would also be based on organic compounds. The notion was strengthened when experiments on Earth demonstrated that organic materials can be formed under simulated Martian conditions.
We used finely powdered minerals like those expected on the Martian surface. Then we added traces of water vapor and radioactive carbon monoxide at low pressure. To simulate Martian sunlight, we irradiated the mixture with light from a xenon arc lamp. When we heated the sample and captured the gases that were formed, our radiation counter showed that the carbon monoxide and water had been converted to organic compounds.
But Viking's instruments failed to detect organic compounds of any kind. That fact, in the opinion of some observers, has increased the odds against the existence of living organisms on Mars.
If we were able to do 1,000 experiments, different experiments on Mars, and to do these in a wide variety of places on Mars, in the canyons, on the polar caps, in some deep areas of the surface, and if in all of these experiments we got negative results, then the answer to the question, is there life on Mars, would almost certainly be no. But on the basis of just a few experiments, done at only 2 sites, very bland sites on the planet, I think it would be unscientific for us to come to that conclusion. All we can really say, for sure, is that we have run across some very interesting chemistry, a kind of chemistry that we do not see in surface samples from the Earth or surface samples from the Moon, and that's about where we are at the moment. Today, in laboratories across the nation, scientists are trying to simulate the results that we obtained on Mars. Some of the scientists are concentrating on irradiation experiments to see whether solar energy acting on Mars could have produced chemicals to account for the results. Other experiments are assuming that these chemicals were there and are testing one or another of these chemicals to see whether they can account for the results that were obtained.
The question of life on Mars is only one of the inexhaustible number of questions for which we continue to seek answers in space. Questions about the origin and evolution of the solar system, of our own planet, and our own species. The search for answers is a goal of planetary exploration, and the journeys of our spacecraft to the near and far reaches of the solar system are beginning to provide some of the answers.
What about this? What you told me before about the ranging? Do you still have some doubts about that, or is everything resolved now?
We're getting good ranging data now, Yuri.
Сейчас мы получаем хорошие данные по измерению дальности.
9/10 of a mile and have him wired.
Super, Tom.
Houston, flight, Цуп, Москва. Корабль «Союз» готов к стыковке.
Sure, the flight director and the other people here in the control center will happy to know that.
I'd like you to know that Apollo is go for Doc also.
Спасибо, Юрий Степанович, очень рада это слышать. Я уверен, что все остальные наши управленцы и руководитель полета будут тоже очень рады это слышать. Что касается Аполлона, Аполлон тоже готов к стыковке.
And if you'll excuse me just for a minute, I'll pass that word on now.
Вы меня сейчас извините, я передам ваше разрешение на стыковку.
You can see his antennas from out here, Dick.
Roger. Apollo, Houston, I got two messages for you. Moscow is go for docking. Houston is go for docking. It's up to you guys. Have fun.
All righty, sounds good. Palovina Mila MXing.
Mid-July 1975. An American Apollo spacecraft and a Soviet Soyuz spacecraft prepare to join in Earth orbit, 140 miles above the Atlantic near Portugal. During their two-day joint flight, astronauts and cosmonauts transferred between spacecraft. They conducted space experiments, and they tested a compatible rendezvous and docking system, evaluating its potential as the universal standard on future spacecraft for docking and rescue. The mission climaxed more than 3 years of planning and preparation, a time during which differences in language, in technology, in political creed were set aside in favor of the common goal. This was the mission that opened the door to international manned spaceflight, the mission that set the course for joint flights of the future. This was the mission of Apollo-Soyuz. In the pre-dawn calm of July 15th, the methodical countdown of Apollo moved with customary precision toward a mid-afternoon launch. Of lesser note was the fact that this would be the last flight of Apollo-Saturn. And as the countdown narrowed, chances are that more than one member of the launch team reflected on other proud days of Apollo, like its 9 flights to the moon, 6 of which resulted in landing men there. Its 3 flights to Skylab, transporting crews to the orbiting space station. And now, in 9 days, the entire Apollo program would pass into history. Apollo would make way for a 2-way reusable vehicle, the Space Shuttle, scheduled for its orbital flight debut in 1979. But today it is Apollo-Soyuz, and as dawn approaches the Florida coast, a similar drama is nearing climax, half a world away. The scene, Baikonur Launch Complex in Kazakhstan, central USSR. The Soyuz spacecraft, its crew approaching the end of pre-launch checks, is about to signal the start of this historic mission.
Ключ на дренаж. На дренаж. Приняли. Летиво. Ее тормоз.
At Mission Control Moscow, flight controllers monitor Soyuz as it gathers momentum en route to orbital altitude. Less than 9 minutes after launch, Soyuz, powered by triple booster stages, is inserted into its assigned orbit.
This is Apollo-Saturn Launch Control. The countdown has proceeded smoothly this morning, and the flight crew here at the Kennedy Space Center were alerted about 10:30. They're right now in the suit room at the Manned Spacecraft Operations Building, donning their spacesuits, and they're scheduled to leave the suit room about 12:37 for the trip out to Pad B. The weatherman continues to be cooperative.
A near-perfect day for the launch, made to order for the thousands lining the roadsides and beaches to witness this Apollo-Saturn finale.
3.1 seconds in the countdown. We'll hold down till thrust builds up.
11.
Engine
10,
ready light on.
9,
10, 9, 8, 7,
6,
5, 4, 3, 2. Engine sequence start. 1, 0. Launch commit. We have a liftoff. All engines building up thrust. Moving out. Clear the tower.
Roger, tower clear. Roger, Tom, you got good thrust on all engines. You're right on the money. 30 seconds, we're on the way. Stand by for mode 1 Bravo. Mark, 1 Bravo. 1 Bravo, 2 Gs. Roger. And cabin pressure's coming down.
Roger. Apollo Houston, you're go for station.
Roger, go for station. Okay, and that light is out on the 4B. We got acceleration.
Roger.
Apollo is placed in orbit.
5, 6, 8, 9. Go.
We're moving
auto.
And before the flight is 3 hours old, the docking module is smoothly extracted from the second stage booster, left trailing behind. During the next 40 hours, Apollo, through a series of maneuvers, will slowly close the orbital gap with Soyuz. The two crews will meet again, not as members of this or that nationality, but as friends who for 3 years shared their separate cultures and customs, and a part of themselves. In preparing for their mission, Soviet and American crews spent a good deal of time together. In formal mission training, in learning about the other man's culture, in getting to know the man himself.
In the United States, I want to visit Hollywood.
Alexei Leonov, Soyuz commander.
Because I want to be a movie star.
Colonel in the Soviet Air Force.
No, I don't want. Tom Stafford want.
In 1965, on the flight of Voskhod 2, he became the first man to walk in space.
Right now, we're optimistic we'll meet the launch schedule. The hardware's in good shape. As far as astronaut and cosmonaut training are in good shape. When you put the whole thing together,
The
that's
Apollo commander, Air Force General Thomas Stafford. Before this mission, he had flown 3 times in space. He was commander of Apollo 10, the mission that orbited the moon and qualified the lunar module for subsequent lunar landings. A civilian and a veteran of the U.S. space program, Donald K. Deke Slayton. One of the original 7 astronauts, he was scheduled to pilot the 4th manned Mercury flight. A slight heart irregularity interrupted his flight career. He was returned to full flight status in 1972 and assigned to Apollo-Soyuz as docking module pilot. Another civilian crew member, Valery Kubasov, age 40, the Soyuz flight engineer. On Soyuz 6, he successfully performed the first welding experiments in the zero gravity of space. Rounding out the American crew, Vance Brand, civilian, aeronautical engineer, former test pilot. He's been a backup crewman on previous flights, but this was his first trip into space. He is the command module pilot. As this was a time of mission preparation, it also brought together engineering and technical specialists from both sides. Heading up the teams were Dr. Glyn Lunny, the American project director, and his Soviet counterpart, Professor Konstantin Bushuyev. Under the direction of these two, an atmosphere of cordiality and mutual respect developed that pervaded the many months of meetings and negotiations. Joint groups were assigned to 5 general areas: communications and tracking, life support and crew transfer, mission planning, control and guidance, and mechanical design. This latter category included the building of the first universal docking system. The system's development, its ultimate testing in space, constituted the specific goal of the Soviet-American Space Agreement signed in Moscow in 1972 by the chief executives of both nations. Although each nation designed and built its own half of the docking system, the interface, that is, the physical mating of the two, was a single design. Considering the language barrier, the differing technologies, two diverse political systems, the development program moved with relative ease. There were differences, to be sure, but none that was above negotiation and compromise. Perhaps Professor Bushuyev put those differences in the proper light. He said, "In our joint work, there has been only one contradiction. Dr. Lunny drinks black coffee, and I drink mine with cream."
Okay, copy.
This is Apollo Control. Apparently the TPI maneuver was indeed successful. Tom Stafford reported from Apollo that he was station keeping with Soyuz. Both control centers, Moscow and Houston, have given a go for docking.
Soyuz, Apollo, как слышать? I need you 5x5.
Apollo, Houston.
Can you see the Soyuz? He's hidden behind the docking module.
Here he comes, just above the docking module. Looks real pretty. Good job. Let's say that. Looking fine.
I am approaching Soyuz.
Oh, please don't forget about your engines.
Less than 5 meters distance.
3 meters.
3 meters. 1 meter. Contact. Capture. We also have capture.
Roger, Tom. We'll pass it on.
Soyuz and Apollo are shaking hands now.
Houston, Apollo.
Go ahead, Tom.
Говорит Professor Bushuyev. Tell Professor Bushuyev it was a soft docking.
Around the world, millions watch and listen as the two spacecraft become one. Now they wait for the next dramatic event, the meeting of Soviet and American crews.
All right, auto show. Открываю loop 3. Okay, the camera. Ha-ha! Got it? Okay, it'll stay open. Go ahead, Tom. Lexi. Just a moment. Okay, turn on the camera. Hit the remote. Okay. Here. Camera. Glad to see you. Here.
Очень рад видеть вас.
Очень рад. Это роща день. Советский Союз. Соединенных Штатов.
In the first crew transfer, astronauts Stafford and Slayton are hosted in Soyuz by cosmonauts Leonov and Kubasov. Vance Brand remains behind to monitor Apollo systems.
In the name of the Soviet people and from myself personally, I am
to mark the occasion, leaders of both the USSR and the United States relay their congratulations.
Of the Soviet spacecraft, new possibilities are opening up for fruitful development of scientific cooperation between countries and the peoples in the interests of peace and progress of all humanity. I wish you successful completion of the planned program and a safe return to Earth. Leonid Brezhnev.
The astronauts are on the line, sir.
Gentlemen, let me call to express my very great admiration for your hard work, your total dedication in preparing for this first joint flight.
It's taken us many years to open this door to useful cooperation in space between our two countries. And I'm confident that the day is not far off when space missions made possible
by this first joint effort will be more or less commonplace.
And may I say, in signing off, here's to a soft landing.
Thank you very much. Thank you, Mr. President.
Among ceremonies scheduled for this first day of joint flight are the exchanges of national flags by the spacecraft commanders. Later, they sign certificates of docking with the Paris-based Fédération Aéronautique Internationale, the organization that validates all aviation and spaceflight records. Finally, they sit down to dinner in space, Russian style.
Right now, I've just finished some strawberries reconstituted. I'm just eating some too. We're getting ready to eat some borscht, as you can see here.
Following breakfast in their separate spacecraft, the crews begin the second day's slate of activities, which includes working on the joint experiments. An electric furnace is aboard for high-temperature testing of metal alloys and crystal material samples. One of these samples is a joint experiment. Investigators believe that uniform mixtures of metals and perfect lattice structures can be consistently achieved in materials in the non-gravity of space. In the day's first transfer, Vance Brand visits Valery Kubasov in Soyuz, and Colonel Leonov is hosted by astronauts Stafford and Slayton in Apollo.
Hello, American people. The first Soviet-American TV center.
Activities begin with a tour of both spacecraft. Kubasov shows Soyuz to the American audience.
Apollo-Soyuz. It's a computer.
Tom Stafford explains Apollo to Soviet viewers.
Очень важно. It's been a most rewarding 2 days here in space, working with the Apollo-Soyuz project.
Soon after the third transfer, the spacemen field questions from the Soviet and American
Soviet
press.
Union and the rest of the world has seen the results of the determination, the cooperation, and the efforts by the governments of the two countries, by the managers, engineers, and all the workers involved. It's been a very rewarding experience.
Roger, it's Moscow's turn to ask the questions that have been proposed by the press there.
Thank you, Bo.
Алексей Леонов.
Насколько считаете вы комфортабельным корабль «Аполлон»? И как вам нравится американская
Consider
пища?
the Apollo spacecraft to be, and how do you like the American food?
Я сегодня
6 часов пробыл на космическом корабле «Аполло», это в космосе. Но as old philosophers says, the best part of a good dinner is not what you eat, but with whom you eat. Today...
North of New England, as the workday ends, Tom Stafford presents Alexei Leonov's spruce tree seeds to be planted in Russian soil, a gift from the American people to the people of the Soviet Union to provide a living memorial to the flight. The spacecraft commanders also join the two halves of an Apollo-Soyuz medal. One half launched with Soyuz and the other half with Apollo to symbolize the link-up in orbit. When time comes to retire to their own craft, it's das vidanya and goodbye. The joint experiments would resume the following day, but only by voice. The next face-to-face meeting would be in Moscow in September.
This is Apollo Control. At acquisition here, we should have confirmation of undocking and a real-time television picture of Soyuz from Apollo as it backs away in preparation for the solar eclipse experiment.
Solar eclipse occurs briefly and infrequently on Earth, giving scientists too short a time for adequate study. But with two-manned spacecraft and proper maneuvering, a solar eclipse can be simulated. Thus, with Apollo blotting out the solar disk, the Soyuz crew train their cameras on the solar corona, recording pictures for later study. They dock again, providing yet another test of the compatible docking mechanism.
Apollo, Houston, it was a beautiful docking. We had a good picture. We can see Italy coming up in the Mediterranean right now. Apollo, Houston through Atson, we're hearing your calls.
Roger. We were docked. Everything was on time, though.
After some 3 hours, the two spacecraft separate for the last time, and Apollo maneuvers into position for the final joint experiment, ultraviolet absorption, the measurement of oxygen and nitrogen particles in the upper atmosphere. Apollo directs light beams of special wavelengths to a reflector mounted on Soyuz. The beams bounce back to Apollo and are there analyzed by a spectrometer. It is the first such measurement by this method. The results have given investigators a clearer knowledge of outer atmospheric makeup, including the quantities of ozone in the upper atmosphere. Termination of the experiment signals the end of the joint phase of the mission, and the separation between spacecraft grows more distant with each successive orbit. Apollo will fly solo for 4 more days, but the crew of Soyuz makes ready for return to Earth.
Good morning again. Jim Hartz and Alan Shepard from the Mission Control Center in Houston, Texas, live this morning. The Soviet spacecraft is about to land in the Soviet Union.
The Soyuz recovery, a focal point of media coverage, is typical of worldwide interest in the mission. Not since the first landing on the moon 6 years earlier has the Houston News Center seen this much press activity. Beneath its single striped parachute, Soyuz settles to Earth in Soviet Central Asia. Retro rockets cushion the impact.
The parachute
3 memorable years have ended. Alexei Leonov and Valery Kubasov have secured yet another place in the history of spaceflight. Apollo continues in orbit, carrying out the remainder of the 27 experiments in space sciences, life sciences, and applications. Among the less notable passengers aboard are numbers of killifish. Sealed in seawater, they are in key stages of maturity. Scientists want to pursue an earlier investigation in which fish taken into orbit on Skylab had orientation difficulties in zero gravity, while those that were hatched in orbit adapted quite well. On return to Earth, the specimens will be compared to similar stages of Earth-raised fish. Through highly refined instruments, they look out in our galaxy and beyond. A new source of radiation is found, the extreme ultraviolet, which many scientists thought would remain forever invisible. Others felt it didn't exist at all. The discovery ranks high in importance and may open a new branch of astronomy for studying the universe. They attempt to locate the sources of soft X-rays. They probe the temperature and abundance of the interstellar medium. They test ways of long-term monitoring of aerosol particles in the atmosphere, which may have profound effects on our weather and environment. They look back on Earth on those features that will yield the greatest results: geological features, the oceans, the deserts, pollution patterns, weather formations, all the phenomena that comes under the general heading of Earth resources. As the mission comes down to the wire, the docking module is jettisoned, and it too becomes part of an experiment. With the two instrumented spacecraft close together in the same orbit, it is possible to measure their relative movements caused by variations in Earth's gravity. The technique provides a means of accurately mapping the Earth's mass structure on a global basis.
Final.
Go.
Guido.
Go.
Retro.
Go flight.
GNC.
Go flight.
Apollo Control, 99 hours, 29 minutes, phase elapsed time. Flight Director Frank Littleton.
Go.
pulsing his flight controllers. ECOM reports everything looks fine.
Go for the burn.
Okay, Crip, everything's up. Great shape up here. The only thing we're concerned about is that you've got all your splashdown parties coordinated, over.
Well, I've been working on that.
Okay, sounds good.
In Pacific waters west of Hawaii, Apollo reaches the end of its journey and the end of an era.
Waving to the crowd, assembled here on the hangar deck of the USS New Orleans. Jack Logan giving them a few more words of briefing about the ceremony, which will take place in just a few moments. Now they walk down a red carpet course. Thank you. I know it's customary to say that it's great to be back and we're happy to be here.
We didn't know it at the time, but during re-entry, gas from the attitude thrusters had entered the command module, creating a hazard. Quick action by the crew in recognizing and correcting the problem avoided a potentially tragic incident. They were later hospitalized in Hawaii for observation and treatment. The symptom cleared in a few days, and the crew was released. The spirit and the letter of the 1972 joint agreement had been dramatically fulfilled. Hopefully it represents a prelude to the future, to a time when all mankind will share the work and the dividends of space. The space shuttle is a major step in that direction. The shuttle will transport into orbit a European development called Space Lab. With 10 countries of Europe sharing construction and cost, men and women of many nationalities will be able to apply their creative talents aboard Space Lab for the benefit of the world community. But for Space Lab, for Shuttle, for all the cooperative space efforts to come, the groundwork has been laid by Apollo-Soyuz, the model for the future.